Alright, here we go. Solutions for the even problems for homework 5-2. Let's start with 12 cosine x plus sine x. Tan x is the more complicated side. Let's rewrite this. Turning everything into sines and cosines. So sine x and then tangent is sine over cosine. We can rewrite this then. We've got cosine x plus sine squared x over cosine. At this point, we're going to need a common denominator. So we've got cosine on the right. We need something here. We'll have cosine. But we also need to add another cosine in the numerator. So we'll have cosine squared plus sine squared, which if we look, let me write it here first. Cosine squared plus sine squared x over cosine x. And if we look at our formulas, we'll see that cosine squared plus sine squared is 1. And so we can flip that over, and our answer will be secant of x. No more, let's see, next slide. No more even ones there, so we'll move on to 18. 18, I'm going to work on the right side and get the left side. So cosine t cosecant squared t minus 1 turns into cotangent squared if we use our formula. So cosine t cotangent squared theta. We rewrite things out. Actually, at this point, I'm going to identify this. Cotangent cubed and squared. We're short a cotangent at this point. We need to multiply by one more cotangent in our numerator, but you can't just magically have them appear, so we need to put a cotangent in the denominator as well, so that really here we're multiplying by just 1. Cotangent divided by cotangent is 1. But now we can move things around. Cotangent squared and times cotangent on top becomes cotangent cubed. We still have one cotangent in the denominator, and we have a cosine. I got messed up with my t's and my thetas. Let me go back and just make these thetas or x's. It doesn't matter, just as long as we're consistent. And so now we've got cosine over cotangent. This part's good. We've matched up here. Can we somehow make cosine over cotangent cosecant? Let's take a look. Cosine theta over cotangent, remember, is cosine over sine. Still had our cotangent cubed here. Not going to touch that though. Instead of dividing by cosine over sine, we can multiply by the reciprocal times sine over cosine. And we get to cancel some cosines out. We're left with cotangent cubed times sine. And if we take sine and drop it into the denominator, we'll flip sine over and make it cosecant. And we'll have our answer. 18, not an easy one. That was a bit of a tricky one. 24, we do not want minuses in the denominator. We're going to multiply numerator and the denominator by 1 plus cosine theta over 1 plus cosine theta. And we'll FOIL this out. So in the numerator, we'll have secant theta. Outside, minus 1. Inside, plus cosecant. And last, for our FOILing, we'll get minus cosine theta. And this is all over. We need to be able to jump right to 1 minus cosine squared theta. Different perfect squares here. So let's clean up the numerator. Secant theta minus 1. Cosine times secant. Secant's the flip of cosine, so that's a plus 1 minus cosine. All over sine squared theta. So we'll cancel in the middle here, and we've got secant minus cosine over sine squared theta. So let's write this out. We can split up our fractions as secant over sine squared minus cosine over sine squared. And at this point, it's a matter of cleaning up a whole bunch of signs. So it's going to get a little messy. Algebra-wise, secant is 1 over cos. And then we've got, I'm just going to look at the numerator here, minus cos theta. We need a common denominator here, so we'll make this cos theta and cos squared. And we've got sine squared in the denominator. 1 minus cos squared is sine squared theta over cos theta times 1 over sine squared theta. This here came from this up here. Let's cancel them out. We'll have 1 over cosine theta. And we are done. We've got secant theta. On we go. 30, problem 30. We're going to solve it out like this. You've really got to be careful with your algebra. Oops, 1 plus sine theta, top and bottom, 1 plus sine theta. Okay? Just going to worry about this first part, and then we'll deal with the 1 here in a second. So let's distribute. 1 times cos theta cotangent theta stays the same. And then we've got plus cosine theta cotangent theta sine theta all over 1 minus sine squared theta. So I want to turn my 1 right here minus into a common denominator. So we're just going to make it 1 minus sine squared theta over 1 minus sine squared theta. And at this point, we know what 1 minus sine squared theta is. That's cosine squared theta. So we've got cosine times cotangent. That's cosine squared over sine theta. Plus cosine times cotangent times sine. Cotangent is cos over sine. So the sines cancel out, and we're left with plus cosine squared theta minus 1. I'm sorry. This turned into minus cosine squared theta. That works out nicely because these guys are out of here, and we're all over a cosine squared theta in the denominator. So we'll finish this off. Cosine squared theta over sine squared, just sine theta, times 1 over, let me erase that, 1 over cosine squared theta. We get to cancel. We get 1 over sine theta, which is cosecant theta. Key on these problems isn't necessarily the trig, it's the algebra. Gotta be careful with these. Let me erase this. And we'll do 36 on the same slide here. All right, 36, cosecant of negative x. If we look at our formula sheet, that just turns into negative cosecant x. Secant of negative x turns into itself without the negative, secant x. And so we'll change these into sines and cosines. This is negative 1 over sine over 1 over cosine. Let's multiply by the reciprocal. So we'll have negative 1 over sine times cosine over 1, which is cosine over sine, which is cotangent. Then we have our answer. We move on to 42. We do not like 1 plus in the denominator, so we're going to go 1 minus cos numerator and denominator. This is all underneath the square root still. All right. The numerator then becomes 1 minus cosine times itself, which is 1 minus cosine squared. The denominator is 1 minus cosine squared theta, which is 1 minus cosine theta squared all over sine squared theta. Remember, 1 minus cosine squared is sine squared. All right, let's take the square root. The square root and the squaring cancel each other in the numerator, so we have 1 minus cosine theta. And then the squared and the square root cancel out here, and we'll get sine theta down here. And since it's in the denominator, we need to have a positive number show up, so the absolute value gets thrown in there. Don't worry too much about the absolute value part of that. If you can get everything up to that point, you've done very well on that problem. 48. We remember this from chapter 4, hopefully. That means draw a triangle. And put a theta in there, and we've got x and 1. Opposite over adjacent. We need to be able to do the Pythagorean to get our adjacent side, and then we want to do cosine of that angle, which is square root of 1 minus x squared over the hypotenuse of 1, and that does equal that. 54, let's take a look at. We're going to clean up the left side, obviously more complicated than the right side, so I'm going to start by writing everything in terms of sine. Cosecant is 1 over sine x times 1 over sine x minus sine x plus, split this fraction up, sine x over sine x minus cosine over sine x plus cotangent is cosine over sine x. It was really ugly a second ago, but look what we get to do. Get that out of here. Let's distribute in. We'll have 1 over sine squared x. Sine x times sine is just 1, plus sine x over sine x is 1. Get it out of here. Get it out of here. 1 over sine squared is the exact same thing as saying cosecant squared x. An ugly problem turns into something pretty in just a few steps. Good job if you got there. And actually, just to be clear here, problems 54, 57, and 60 are asking, is it an identity? Is our problem an identity? Alright, so on this one, we did solve it, both sides equal, so yes, it is an identity. 60 is not going to be an identity, as we will see here in 1 second. Let me erase this, and I'll do it on the same slide. All right, let's clean up this denominator here with a cosecant alpha minus 1. Numerator and denominator. So our numerator becomes cosecant alpha cotangent alpha minus cotangent alpha over cosecant alpha squared minus 1. And if we go into our bag of formulas, the denominator turns into cotangent squared alpha. In the numerator, actually, I'm going to pull that cotangent back out so we can cancel it now. Cotangent alpha, cosecant alpha minus 1. Back from over here. I'm doing that now because I see we can cancel some cotangents here, and we've got cosecant alpha minus 1 over cotangent of alpha. Is this equal to this? No, it's not, because we've got opposite signs. So 60 is no, not an identity. All right, let's bring this home with number 66. Cosine squared of 55 plus cosine squared of 35. We're going to go to our complementary formulas here. Cosine squared of 55 plus cosine squared of, another way of writing 35 is 90 degrees minus 55 degrees. And if we go into our complementary formulas, we can say cosine squared of 55, leave that alone, plus, switch this to sine squared of 55 degrees. And we should know at this point what cosine squared plus sine squared of the same angle is. That's just 1. All right, so there you have it. Those are your even answers for section 5.2.